The first part of 12.4 is about writing probability distributions and defining sample space and the uniform distribution. So this first example, we're looking at a box, and it contains 3 Henry buttons and 3 tail buttons, and we're saying that we would like to pick either 0 or 1 tail buttons, and we're picking just once. So the probability of getting 0 tail buttons means that we got a Henry button. So the probability would be 3 out of 6, which is the same thing as 1 out of 2. And then the probability that we get 1 tail button means that we got a tail button, which would be 3 out of 6, which is 1 over 2. Okay. We've done this before. This isn't new, but we're going to introduce some new language. The probability distribution is going to be a function that assigns a probability to each outcome of an experiment. So the sample space is all the things that could happen. Since we were counting tail buttons, all the things that could happen would be 0 or 1. And the probability each time was a half. Since these probabilities are the same, we say that that's a uniform distribution, so that the probabilities match. That means it's uniform. I'd like to point out that if you add up your probability distribution, you should get 1, because those are all the probabilities of all the things that could happen. So you should get 100% for that probability distribution. Okay, for the second example, we're going to pick 2 buttons. We will pick a button, put it back, and then we'll pick another button. So for these kind of problems, I like to draw a tree. So I like to say here, not a tree, blah, 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 that would be funny. But what I mean is a tree diagram. So the first pick, there are 2 possibilities for my first pick. I could get a tail button, or I could get not a tail button. And the probability of picking a tail button out of this box is 1/2. The probability of picking a Henry button out of this box is also 1/2. I put the button back in the box, and then I pick again. So the probability for tail is still a 1/2, and the probability for not tail is still a 1/2. And then I do the same thing for if I picked a not tail first. And then to get the total probability, I'm going to multiply each branch of the tree. So on this branch of the tree, it'd be 1/2 times 1/2, which is a 1/4. And this branch of the tree would be 1/2 times 1/2. And there it looks like they're all 1/2 times 1/2. So they're all going to be 1/4. And then I'm going to look at the branch of the tree that represents 0 tail buttons. So I was unsuccessful both times. This is this branch of the tree. That probability is 1/4. Then I'm going to look at the branch of the tree where I got 1 tail button. So one time that I did that is I got the tail button on the first try. So that would be a 1/4. And another time I did that, I got the tail button on the second try. So that would also be a 1/4. So I'm okay with either getting tail button on the first try or getting tail button on the second try. So I'm going to add those 2 probabilities together. I get 2/4, which is 1/2. And then for the last one, I'm going to look at the probability of getting a tail button each time. So that would be this branch of the tree. So that would be 1/4. So for this experiment, my sample space was 0 tail buttons, 1 or 2, and the probability distribution was 1/4, 1/2, 1/4. And for this experiment, the probability is not uniform because these numbers are not the same for every situation. All right, so for this example, we're going to pick a marble out of this jar of marbles that has 3 green and 2 red, and then put it back, and then we'll pick again. So for this experiment, we're going to put it back. I'm going to encourage you to pause and try drawing a tree, we want to either get a red marble or not a red marble, because we're counting the number of red marbles that we pick. So go ahead and pause, and when you think you've got it, I will talk through this solution. Okay, so for the first pick, we're either going to get red or no, and the probability of getting red on the first pick would be 2 out of 5. The probability of not getting red is 3 out of 5. Since I'm putting the marble back, those probabilities are going to stay the same. So red and red and red and not is going to be 2/5 and 3/5 here. And then not red and then red, that would be 2/5. And then I'm going to multiply my branches. The reason I know to stop my tree here is that I was picking one marble and then picking again. I wasn't picking another time, so I'm done with my tree now. So that would be 4/25 that I get 2 reds, and 6/25 that I get a red and then a not red, and 6/25 that I get a not red and then a red, and 9/25 that I get 2 not reds. So the sample space would be 0 reds, 1 red, or 2 reds. The probability distribution is going to be 9/25 would be 0 reds. For 1 red, we're going to look at this branch of the, we're going to look at 2 different branches of the tree. We're going to look at this branch and also this branch, because both of those branches have 1 red in them. So we would add those 2 branches together, and we'd do 6/25 plus 6/25, and that would be 12/25. So that's the probability of 1. And then the probability of 2 reds would be this branch of the tree, so that'd be 4/25. Is it uniform? No, it's not, because those 3 numbers are all different. So this is not a uniform distribution. All right, if you didn't try the other one on your own, please try this one on your own. The only difference here is that we are not putting the marble back. So our probabilities are going to change along the way. The sample space will stay the same. It'll be 0, 1, or 2 reds. And the probability distribution is what you want to figure out. I will be back in a moment with the answer, so you need to pause so that you can try the problem. Okay, here's my solution to that example. I made a tree. I made sure that my probabilities changed for my second draw because there were fewer marbles in the bin. When I did my second draw, if I'm holding a red marble, the probability that the second one is red would be 1 out of 4 because there's 1 red left. The probability that the second one is not red would be 3 out of 4. And then the probability distribution is going to be those 3 probabilities. And it is not uniform because those probabilities are all different. I added these 2 probabilities together because those are both events where I got 1 red marble. So at this point, you should be able to write a sample space, you should be able to write a probability distribution, and you should be able to tell whether a probability distribution is uniform. So this is the first half of section 12.4. Thank you so much. Bye.